All right, so this is our second video for 12.6. In the first video, we talked about cylinders, different kinds of cylinders that we could have, and kind of how to go about sketching those. Well, we're going to continue that, talk about some more specific quadric surfaces. The next one is what's called the ellipsoid. And if you kind of look at the root word there, you know it has something to do with an ellipse. So let's take a look at some of the criteria here for an ellipsoid. So the criteria is that all variables are squared and all are positive. And as you can see, you have x squared, y squared, and z squared. They're all positive variables, no negatives out in front, equals 1. So in 3D space, so what we want to look at here is all of the different traces. So when I say traces, you could look at this thing in several different planes. If you were to look at this, oops, didn't actually want to do that color. If you were to look at this in the standard XY plane, that just means make z 0. So if I make z 0, you're going to have x squared plus y squared equals 1. Well, hopefully you recognize that is nothing more than a circle with a radius of 1. So something like that. Okay, if you were to do this in the xz plane, letting y equal 0, x squared plus z squared equals 1. Once again, this is going to be a circle with a radius of 1, and I'm not going to draw the last one. You get the idea. They're all going to be circles with a radius of 1 depending on which plane you look at it. So let's go ahead and sketch what this would look like in 3 dimensions. As a matter of fact, let's go ahead and extend these axes. So each one of these things is going to have a trace of a circle. So the XY plane is a trace of a circle. Something like that. Looks kind of more like an ellipse. But that's okay because a circle is just a special ellipse. XZ plane, I did in green, so I'll try and keep this in green. See if I can do this. This is actually the hardest way to do this. This is going to look awful. I'll show you a better way to draw this in a second. And then I didn't use a color, so I'll go with blue for the YZ plane. So the YZ plane is going to be in this specific direction. Boy, this is really difficult. This is not going to look good at all. Okay, so let me show you an easier way to do this because this is not easy to do from that perspective. Again, drawing the traces individually, if you're good at it, not so hard. For me, oops. For me, drawing these traces individually like that is not the easiest. Hopefully we all recognize what this thing actually is. It is a sphere. So to me, the easiest way to draw a sphere is to go ahead and draw a circle. It looks like it's centered around the origin. And then I'm going to try and do my best here to three-dimensionalize this thing. So I'm going to draw the front of it coming out like this. And then I'll dot the back of it going around the back side. And then we're going to do exactly the same idea from the top. Draw the front of it, and then we'll draw the back of it. And spatially, that looks much more like a sphere. All right, so that's what we have here. We have a sphere. So obviously, if the x squared, y squared, or z squared were divided by something different than the other ones, then you would have much more of an elliptical shape like the one in example 6. This one's going to be a little bit more challenging. So the first thing you probably want to do here, because you should kind of recognize that this is an ellipsoid by its components, all positives, all squares, you just kind of want to find the intercepts. So let's go ahead and I'm just going to sketch the X, Y, and Z here. All right, now let's see how this goes. Let's find the intercepts. if I want to find the x-intercepts, that means y and z have to be 0. So the x-intercepts are going to be at plus and minus 3. So 1, 2, 3, 1, 2, 3. So you're going to have your x-intercepts at plus and minus 3. The y-intercepts are when x and z equal 0, so that'll be plus and minus 2. So 1, 2 in either direction. You can definitely see how that'll be an elliptical shape in the xy plane. And then in the z direction, it looks like positive and negative 1 if we let x and y be 0. So that'll just be like right here and right here. Again, this will not necessarily be the easiest thing to sketch, but I will do my best. All right, so let's see what happens here. So the YZ plane is going to go up through 1 here, down through negative 1, and back around. Okay, that's not bad. Again, you kind of have to imagine that being flat on the YZ plane. All right, now let's try to do the XZ plane. So that's going to start on the x-axis, go up through z equals 1, down through z equals negative 1. Not the best. Did not do a very good job. Take that away. Try again. Okay, as you can tell, this is going to be kind of a long and skinny one. And then we have to do on the XY plane. So let's try the XY plane, which is going to go like this. Okay, that's actually not horrible. Again, probably not the easiest way to draw this thing, but now that you kind of have the general idea what it looks like, we can kind of draw it as, I don't know what you would call it, maybe like a pill or a football kind of a shape or something like that. So you've got that part right there, and then we're going to have the top of it coming around like this, dot the other side, and then we'll do the same thing in the more the vertical direction. So like this, we'll have the top of it, and then we'll dot the bottom piece coming up around there. So that kind of gives it much more of a dimensional shape there. Again, not the easiest things to draw, but the idea is figure out what the shape is by the by what the equation looks like, so you have somewhat of an idea, and then use the traces. Use the individual traces to kind of help yourself with these things. All right, let's go ahead and move along to a different shape. Slightly easier to draw. These are what are called elliptic paraboloids. So one variable is raised to the first degree, and the other two are squared, and they have the same sign. So you could have, in this case, we have x equals positive y squared plus z squared. We could have x equals negative y squared minus z squared. They must have the same sign in order for that to be the case, to be an elliptic paraboloid. So let's go ahead, and this one we're actually have to do a little bit of work. Drawing these is actually easier, but like doing the traces and figuring things out, not quite as easy. So let's say, let's let x equal 0. If x equals 0, that gives us the equation 0 equals y squared plus z squared. Well, technically that's a circle with a radius of 0, so it's really not a circle at all, it's a dot. It's just a point. But what happens if we let x equal 1? Well, then we get 1 equals y squared plus z squared. Now we get a circle of a radius 1 sitting on the yz plane. Let's go to x equals 4, only because it's going to be easier to deal with than root 2 and root 3. So we get 4 equals, oops, that should be a y squared plus z squared. So now we get a circle of a radius 2, and so on. Well, let's try x in a different direction. Let's go with x equals negative 1. Well, if x equals negative 1, we get that negative 1 equals y squared plus z squared. Well, there is no way to get negative 1 out of y squared plus z squared. So this part right here leads to no solution. Which means that there are no values in the negative x direction, because you can't have that. You cannot have y squared plus z squared equaling a negative value. It just doesn't exist. Okay, Well, that's if x equals all these values. Now let's try y, because this is developing our traces. So let's say if y equals 0. Well, if y equals 0, we get x equals z squared, which we know to be a parabola. Well, what if we let z equal 0? If we let z equal 0, then we get x equals y squared, which again we know to be a parabola. So hopefully you can understand by looking at these traces why this is called an elliptic paraboloid. The first part, where you let the variable with the first power be different numbers, those are your ellipses. In this case, they're all circles, but again, circles are ellipses. In the second part, for the traces, we let the squared parts be 0, and then you're going to get your parabolas. So you get an elliptic paraboloid. So again, let's go ahead and sketch this and see what it looks like. And there is a specific reason why I am not sketching all of the different traces. It's actually something you guys will be able to do. All right, so let's see here. I went out to x equals 4, so let's just kind of go out to x equals 4 at least and see what that looks like. Okay, so what I have is at x equals 0, I have a point. Good, right at the origin. At x equals 1, I have a circle with a radius of 1. So surrounding 1 here, I've got a circle of a radius of 1. And then at x equals 4, I've got a circle of a radius 2. Slightly bigger circle. So hopefully you can see that as this thing gets bigger, at x equals 9, I'm probably not going to do it justice way out here, but x equals 9, you'd have a circle of a radius 3, something like that. And then the trace in the xy plane, is a parabola. Now this parabola opens what would normally be sideways for us if we were in the xy plane. So the parabola opens sideways, which means it's going to look something like this. It's going to be kind of a skinnier parabola. That's not too bad. I'm hitting the outsides pretty okay. All right. So there's my outside parabola. That's on the xy plane, so kind of picture that sitting flat on the xy. And then we're going to have one on the xz plane. So it's going to be kind of up against what you would call maybe the left wall, if you think of it that way. The xz plane, so that's going to start up here at the top. It's going to cover the tops of these things, come down to here, and then go down around the bottoms out to there. So that's going to kind of be your elliptic paraboloid. I probably should have dotted that bottom of the orange one right there. So that's an elliptic paraboloid. Again, now, if you ask me, the easier way to sketch this, just kind of do it real quick here, would just be to kind of draw yourself something that looks a little bit like a sideways bowl, like that. That's kind of your elliptic paraboloid that opens in the direction of the positive x-axis. All right. Graph the equation z equals x squared plus y squared. Once again, same exact idea. We are not going to go into all the different detail here. The main thing to recognize is, first of all, z is the variable that's only got a power of 1. So this is going to open up around the z-axis. X squared and y squared are both positive, so it does open in a positive direction. So again, the easiest thing to do is kind of sketch yourself a little bowl, because it does say sketch. It does that. Okay, there's not much detail in that one, obviously, but that is a sketch of the graph of z equals x squared plus y squared. So the sooner you can start recognizing which ones you're looking at, the easier this will become. Okay, let's look at one more. Elliptic paraboloid. Because remember I said that both of the signs had to be the same. Well, we can see that z is the power of 1. But then we get 9 minus x squared plus y squared. So if I distributed the minus, you would get a negative x squared minus y squared. So both of these things would be negative coefficients. So real quick, if we let z equal 0, what you would get is 9 minus quantity x squared plus y squared equals 0. Adding the x squared plus y squared to the right side, you would get that 9 equals x squared plus y squared, which is a circle of radius 3, and that's when z equals 0. So that means on the xy plane, you get a circle of radius 3. So we'll go ahead and sketch that part. It also says, well, what if we let x and y both be 0? Then you get z equals 9. So we know that this thing is going to top out at z equals 9. And the minus sign right there indicates really that this thing should be opening down. Just like if you would have, z equals 9 minus x squared. Opens down, intercept at 9. Same exact idea. So again, we're not going to sketch everything perfectly here, but we're going to start up where z equals 9 would be, and then this thing's going to come down. And this down here would be your circle of radius 3, not drawn to scale at all, but that is the general idea of what we're looking at there. Okay, so again, I hope this is starting to make sense. You can kind of start picturing these things. We are going to stop it here, and we're going to come back with one final video, and the final video is going to incorporate one of the more difficult ones to draw, which we will actually not draw by hand, and then a couple of the other concepts that we will draw by hand, which are really not that difficult.